Hello everyone. Today we will study the relation connecting frequency and time period of a sound wave. So, what we have studied about frequency, children? Frequency is the number of waves crossing a point in the medium per second or in 1 second. So, let F be the frequency of the wave. That means F waves cross a point in 1 second. F waves cross a point in 1 second. So F is the frequency. So what is the time taken by one wave to cross the point? So am I right? Time taken by one wave to cross a point. To cross, that will be equal to 1 by F. That means F waves cross in 1 second. So time taken by one wave is 1 by F. So children, what is the time taken by one wave to cross the point? It is, of course, it's called the time period of a wave. So time period is equal to 1 by F. So this is the relation connecting time period and frequency. Oh, we can say that time period is the reciprocal of frequency. If we want to find the frequency, what will we do? We'll take the reciprocal of the time period. So F waves cross the point in 1 second means F is the frequency. Time taken by one wave to cross that point is 1 by F. So, in other words, what is the time taken by one wave to cross the point? It's called the time period. So, time period is equal to 1 by F. Or we can write that F is equal to 1 by T. So, I hope that you got the point. Next topic, we will study the relation connecting wavelength, frequency and speed of a wave. So listen children, a compression and a rarefaction is there. This is a reference line. So after some time, we assume that this compression and rarefaction has crossed this reference line forward. So a compression and rarefaction is there. The wave is moving forward. So a compression and rarefaction will cross this reference line forward in a particular time. So, what is the distance that this compression and rarefaction travels when this completely cross this reference line? So, what is the distance traveled by the compression and rarefaction? We know that one compression and one rarefaction constitute wavelength lambda. So, children, according to definition, what is the time required for a compression and a rarefaction to cross this point? So that is given as the time period. So for crossing the reference line, the wave or the compression and rarefaction has traveled a distance lambda, right? And what is the time required for it? It is t. So we have studied in the chapter motion. The speed is given as, what is it? Distance by time, isn't it? So, let the speed be denoted by v. What is the distance traveled by the compression and the rarefaction when we cross the reference line? It is called lambda. And what is the time taken for it? It is the time t. So, v is equal to lambda into 1 by t. Children, what is 1 by t called? We have already explained. What is 1 by t? 1 by t is the frequency of a wave. So, we can write that the speed v of a wave is lambda into f. This is a very important relation connecting the speed, lambda and frequency. The speed of a wave is the product of its wavelength and frequency. So once again children, We consider the compression and rarefaction crossing a point. The distance travelled by the compression and rarefactions while crossing a point is denoted as wavelength lambda, and the time required for it is t. Speed is equal to distance by time. So speed is depicted as v, distance is depicted as lambda and t. So we will get v is equal to lambda into 1 by t, and 1 by t is frequency. So speed is equal to wavelength into frequency. So what is the relation connecting speed, wavelength and frequency? Speed is the product of wavelength of a wave and its frequency. So please note the point. This may be useful for your higher classes also. Hope you understood, children. Thank you.